This is a wonderful occasion for all of us, as we're going to hear from Ed McCann, who's here this evening to deliver his presidential address. It's already a long-standing traditional engagement between the ICE and Engineers Ireland, and it's our intention that it will continue long into the future. Ed is president of the ICE. Ed, you're very, very welcome to Dublin and indeed to Ireland. We're delighted to have you with us. This address is an extremely positive collaboration between both institutions, which share many common purposes, including supporting our members to be the best engineers they can be throughout their careers. The Institution of Civil Engineers has put decarbonisation at the heart of its agenda, alongside climate resilience, productivity, digital, and other key transformation strands. In the ICE 22-25 plan, you aim to deliver against the UN Sustainable Development Goals and demonstrate the important role civil engineers have and will play in creating a stronger, more resilient and sustainable world. In Engineers Ireland, sustainability is at the heart of our agenda. Our vision statement, for example, is a community of creative professionals delivering sustainable solutions for society. I know, Ed, as part of your presidency, you're putting quite a focus on productivity and how engineers can increase efficiency and effectiveness whilst reducing waste. During the talk, I understand Ed, the president of the ICE, would accept questions throughout. There will also be Zoom questions that will be taken by Alec or Maureen, and they will come through the system also in the course of the evening. The title of Ed's address is How Civil Engineers Can Survive and Thrive in the 21st Century. And before I call on Ed to deliver his address, I'd like to tell you a little bit more about him. Ed McCann became the 157th president of the Institution of Civil Engineers in November 2021. He graduated from the Imperial College in London in 1989 with a degree in civil engineering. During 12 years with Binney & Partners, he obtained a master's degree in hydraulic engineering and worked on some 50 infrastructure projects all over the world. He joined Expedition Engineering in 2002, where he has been the project director for many projects, including the multi-award winning Infinity Bridge and Olympic 2012 Velodrome. Ed was instrumental in the growth and development of Expedition, from a back bedroom startup to Building Magazine's Engineering Consultant of the Year in 2012. In 2009, Ed co-founded the Useful Simple Trust and gifted his shareholding in Expedition to the Trust for the benefit of the employees. Ed has been actively involved in design education since 1999. He is a Royal Academy of Engineering Visiting Professor of Innovation at Strathclyde University. Ed lectures widely and has also made some 35 television programs about civil engineering. Ladies and gentlemen, please give a warm welcome to Mr. Ed McCann.
Well, thank you very much, John. There is nothing quite as excruciating as having your CV read out to you. But anyway, here we are. Look, first of all, a huge thank you to Engineers Ireland for the invitation to join you this evening. Like John, I think it's a fantastic fact that we meet each other each year and we listen and learn from each other. The connections between us as institutions and as sort of a group of engineers working across UK, Ireland and around the world is very, very strong. For me in particular, it's fantastic to be in Ireland. Those of you who know the name McCann will have recognised it from various places around Ireland. My family hails from sort of Ulster. The McCanns are from Ulster, but the Smiths on my grandfather's side are from Dublin. So there's a place called Smith's Yard off O'Connell Street, which used to have a hackney carriage business where my family sort of hail from. But I am part of the Irish diaspora, in fact. You know, my parents left because there was no work in the late 50s, early 60s and turned up in London with £5 in a suitcase, as many Irish people of their generation did, and we found ourselves in West London, or I wasn't born then, but they found themselves in West London, part of a community actually of Irish constructors and builders. Everyone I knew worked in construction one way or another. I went to school. The school I was in, 30 kids in the class, 20 of them were Irish, or children of Irish people. So I think it's interesting to note just how significant the Irish island has been in generating engineers and constructors, not only in the UK, but across the world, notably in America, New York, and so on. So I don't know why it is that the Irish make great engineers and great builders, but they certainly do. And I think, the tradition continues. And if you go to London today, you're going to find London being built by Irish companies. Our most notable businesses are Irish contractors. So well done. Keep sending them on because we need all we can get. So a little bit about that background. I mean, I think what was interesting, what John says, and I've heard all say it before, is we engineers, it's not in the end about the money. We perform a really critical societal function that dates back to the dawn of civilization. 10,000 years ago, when the first things called towns and city emerged, there were people in them who somehow or other contrived or imagined and then built infrastructure, whether it was houses, bridges, the lifting machines that pulled water out of rivers. All of that has been going on. It's integral within human society. And we perform a vital function for society, providing the infrastructure that society needs to survive and thrive. And as we stand here sort of in the early decades of the 21st century, our role has a heightened significance because a lot is changing. We face truly existential challenges in the 21st century as we try and accommodate a population of, let's say, 10 billion people on this planet without completely destroying it, because at the moment our mode of being is damaging the planet that we live on to an extent that is simply not sustainable. Yeah, so we don't have to think very hard about the specific nature of the challenge. Lots of people have been doing that. These are the UN Sustainable Development Goals, and I think they nicely frame what we're trying to achieve in the 21st century. And you'll all be, I'm sure, familiar with them in one way or the other, but I think, that's it on a page. That's what we've got to do. And if our projects are not doing this, we need to ask ourselves, well, what are they doing? If they're not doing one or many of these things, they're not doing enough. So we frame that challenge, and then so there's our challenge. And let's talk about productivity a little bit in the context of that challenge. It's a term that we use a lot. You'll hear politicians talking about it endlessly. If I went around the room, every single person here would have a subtly different way of defining it. I think I'm not going to go into economic definitions of productivity. I'm much more interested in how we understand productivity as engineers. And what we found when we look at this is there are two dimensions to productivity that are really helpful as we frame a debate about how do we improve productivity. And the first of them is effectiveness. Doing the right thing. If I said to you, have you had a productive day? You're more likely to answer that question in terms of, I achieved what I wanted to achieve. I won the prize. I wrote a poem. It's about the outcome. And you would go, I've achieved it, therefore I've had a productive day. If you were to talk to a process engineer, they'll start talking about ratios of inputs to outputs. They said, was it productive? Well, if the outputs were good in relation to the inputs, then that's more productive. And so you get these two ideas of effectiveness, does it do something useful? And efficiency, is the ratio of inputs or outputs really good? Lots of outputs for little inputs. And it looked at another way, you can say that that's about doing the right things and doing things right. Efficiency is really about eliminating waste. And for those of you who are familiar with the sort of manufacturing world and the Toyota production systems and the whole origin of lean, if you get into it and look at it really carefully, it's basically the fundamental tenets of their philosophy are focus on value, get value right, make sure that you're doing something that the consumer wants, that the client wants. The car's going to be a great car. And if it's not, it won't sell. So what's the point of any of it? And then the second thing they do is they go after waste. They eliminate waste ruthlessly. And that has been why a ruthless focus on those two ideas is why cars are cheaper, faster, more economic, less environmentally harmful, and better value for money in real terms today than they were 20 years ago. That is the strategy they deployed. Focus on value and eliminate waste. If you look at our industry, slabs are thicker, columns are thicker. Unit outputs are more expensive than they were in real terms 20 years ago. We have not managed to do what others have managed to do. And I think the reason is we don't have sufficient focus on this. And many may say, oh no, it's completely different. We're in a field, it rains. We're not like cars, and there's truth in that, but we'll come back around to it. So this I find to be a useful definition for us when we're thinking about engineering. We improve productivity when we improve effectiveness and when we improve efficiency. So what's going on in infrastructure? And I've focused on infrastructure here. The same is true in general of all construction activities, but the infrastructure productivity challenge. Now, it's almost a truism in our industry that we're not productive enough. We started writing, the first report I've ever found talking about deficiencies in the construction industry dates from 1937. It's called something like Castles in the Sky. And it's a review into why is housing costing so much and why can't we do more of it and why is construction so useless? And roughly every decade, we have a flurry of reports which are basically looking at our industry and go, why isn't it better than it is? Why don't we have manufacturing type performance improvements? And this is a recent sample of the sort of thing that's been floating around for the last couple of decades. And they, in essence, all point to the same system problems in different ways. Oh, I didn't want to show you that. No one noticed the numbers, did you? Right. So okay. So there's a piece of work. If I said to you, an infrastructure project, when you start a project and you say, you've got your business case, you say, I want this project to achieve this outcome. So here's my business case outcome. I want that. I want it also to be on time, and I also want it to be on budget. And I think I just had those three things. It's going to cost what it says it's going to cost. It's going to take as long as to build as I thought it would, and it's going to deliver the benefits case. So the question for you all is, what proportion of our projects, out of a sample of 16,000 around the world with an average price of about $80 million, what proportion of those achieve all three of those targets? 10, 20%? Anybody feeling more pessimistic? 5? 0.5%, and that was what that graph shows. So of all projects, this is work done by the University of Oxford Side Business School, 16,357 projects around the world, 47.9% were on budget or better, 8.5% on budget and on time, and less than 0.5% on budget, on time, on benefits or better. This is not good. It's certainly not good enough. And Bent Flyberg, who leads this research there, has this phrase, over budget, over time, and under benefits, over and over and over again. When they break down those projects into the sort of things we're familiar with, if you just look at the sort of stuff in the infrastructure space, so roads have an on average overrun of about 16%. So the quantum is 16%, rail 39%, buildings 62%, IT-led change projects 73% overrun, dams 75%, Olympics 157%. That is cost overruns when compared to the business case in which the investment decision was made. Of course, people change their minds and they come along later and say, oh, it's going to make less than I thought it would. It will cost more and all the rest of it. But if you are an investor client, that's what you're seeing. And you see the same kind of rather dismal pattern as you look throughout it. And this points to a really significant problem in terms of our projects, both are they effective? No, they don't deliver the benefits case in the way that they're meant to. And are they efficient? No. They're not delivering well. I mean, you could say it's all about not having the estimates right. So I'm not going to make too many claims just on the basis of this, but that's nonetheless, it's still a pretty poor picture. So let's talk about effectiveness a little bit and think about the projects that we know and love and ask ourselves, did they work? And I'm going to mention Olympic projects, for example. So I went to visit the Athens Olympics in 2004. And don't quote me on these precise numbers, but after the games, I think it was 17 out of 19 stadia were never used anything. And so the white elephant Olympic phenomena, which is it's one of the reasons why on London, we only had 5 permanent venues. Everything else was temporary. Because what we were trying to do was eliminate that gross wastage in construction that would then just sit there gathering dust, which has characterized, by the way, Rio subsequently. So it didn't stick. That logic didn't stick. The road projects that don't deliver. The road to nowhere. I heard a story about one out there, just here in Ireland, just today. A great big scheme that has no cars on it. No. Rail projects that are grossly underutilized. And so this is not unfamiliar. I could go on all day. All of those numbers have a story in them. Ports and harbors that don't get to 10% of the predicted utilization rates when they were set up. Airports, regional airports all over Europe that are not doing the sort of passenger numbers they thought they were going to. Yes, yes.
I don't think we have any roads in this country. But you're right. The general direction of travel is correct. And isn't this all about the circular economy? So that multi-use is not multi-use. It doesn't apply. You have to get sufficient life use out of every asset to make it worthwhile.
I think that I agree with that point, but I think the first thing is to realize that it's very hard for us to predict what demands look like in these sorts of systems. And sort of we have an approach to planning infrastructure, which is really quite deterministic. It is we predict in this way. We imagine the future as if it's a certainty, and we're wrong. We're wrong all the time. And we're wrong in the wrong direction a lot of the time as well. So I think the point I would take away from this is you almost need a different way of understanding how to make decisions when you're confronted with uncertainty in the future. That's a very important part of this. But I will return to the circular thing because I think it is very important. But so just on effectiveness, just to ask yourself, is this project doing what it was meant to do in toto? Does it? And the answer is too often not. So efficiency, and this is one where you should all be screaming at me that I'm wrong, but I led a research project a few years ago looking at project costs and their relationship to error in the UK. And in the end, we ended up looking at a number of international comparators and the best work that's been done on this is actually in Australia, but it references projects in Northern Europe. And it is this, that 10 to 25% of project costs in the construction industry arise from avoidable error. 10 to 25%. Aggregated across new build construction in the UK, the average, by the way, that the sort of mean, in numerical mean, is at about 21%. That was what this research concluded. In the UK on new build projects, that's £21 billion a year that we spend as a result of error in our construction projects. We should be invaded by the National Audit Office at this moment. They should come running in and say, what are you doing? Can you imagine that sum of money? Unless you are actually a government, you don't get to waste that amount of money. It's not allowed. So 25 to 50% of structural materials are not necessary to comply with codes. So we talk about carbon, we talk about net zero. But if I was to pull out here a whole series of design drawings and we would sit down and sharpen our pencils and start looking at me, does that beam need to be 300 thick or could I get away with 250? Do I really need to have the same reinforcing steel everywhere on this beam? Loads aren't the same. Bending moments aren't the same. Why is it steel all the same everywhere? And there are reasons. There are reasons to do with ease of construction. There are reasons to do with I'm scared. I don't know if I've got my sums right, or I'm worried that the contractor is going to mess it up and I'll have to change it later. All of that sort of stuff. But the net consequence of those contextual factors is that we're over specifying concrete and steel and glass and timber by 25 to 50% over what we should be doing. And in a world where we're sitting here going that 8% of global carbon emissions are associated with cement and concrete, and we're all running around trying to invent new cements. What sense is there leaving behind overspecification and error-generated waste? Codes, in the end, in any case, are designed to cater for the least competent designers, contractors, owners, operators, and users, and are hence generally very conservative. A good friend of mine in the aviation industry said, if we designed aeroplanes like you design buildings, they would never fly. We work on the basis, our design codes are based on the idea that contractors are useless fools who cannot build correctly. And if you think that's an absurd statement, does anyone want to tell me what the factor of safety, partial factor of safety on workmanship for masonry is? So this is the number that we multiply our loads by because we say that bricklayers can't lay bricks straight. What is that number? 3. It's 3. The guy from the National Audit Office should be running in. He should be running in. Imagine if we designed planes on the basis that the people who put them together wouldn't put the rivets in, wouldn't make the welds, that the people who were making the aluminium wouldn't do their jobs. But that's what we do all the time. I'm working on projects at the moment where we are making tunnel segment linings in a factory. Brilliant, amazing factory, poured to the millimeter, vibrated, cured, steamed, you know, the most high-tech construction facilities you can manage. And then you say to them, have you used factors of safety in the design of that relate to factory construction or in situ construction? What do you think the answer to that question is? In situ every day of the week. We're putting 10% more material in, and because we can't be bothered to challenge ourselves on the specification. And this is all over the place. Sorry, I'm sounding really negative here. But anyway, 10 to 15% of materials by value brought to construction sites are wasted. Now you should turn around to, no, can't be possible, can't be possible. Can anyone in the room tell me what proportion of concrete brought to construction sites goes on the floor? So I've got it on the drawing. We know how much is going into the drawing. How much goes on the floor? If we were in manufacturing, we would know the answer. We'd know the answer to half the percentage point.
We probably 10 or 20%, but if you bring in BIM and modern method construction, it should be 0.
Indeed, but it isn't. And you know, interesting what the root cause is you know why we're wasting so much concrete. There are a couple of things. One of them is like piles. We have methodologies that mean we over pour and then chop the top off and throw it on the floor. So we actually build it in. And there is a question about, well, is that a good process? There are people who've come up with zero trim piles. There's a really clever bit of thinking on how do we do zero trim piles, which has been pioneered on HS2. It has been possible to do zero trim piles for years, but we haven't done it. And it's typically 50% of the concrete that's brought in to do piling goes on the bin. But do you know what the other really big reason for this is? Site engineers sitting there with their calculators in the rain, and the general foreman standing beside them shouting at them, you better not leave me short here. It's late in the afternoon. If you come up short on this pour, I'm going to chuck you in it, you know, and they're terrified doing their sums on the back of it. I tell you what, it says 4.5. Let's just get a full wagon. Let's get 6 in. And then you've turned concrete into general fill. That's what you've done. And in the worst of circumstances, you're filling up skips and paying £200 a cubic metre to get rid of the stuff. So this kind of stuff, again, we're all sitting in, you're not shouting me down. You should be telling me, Ed, you're mad. There's no way we are doing this, but we're not, because this is our industry. This is what we do in our industry. Construction programs and schedules, circa 17% suboptimal. So what this is about the fact that when people do construction programming, if you took that program, your P6 program, and you sat it to the side and you got algorithmically optimized it, balancing resources and program, you get 17% back. But we don't do that. In fact, our whole approach to construction planning is defective at the moment. We've got P6 programmers who are really good at software, but don't know that you put piles in before you put roofs on. And so you get dysfunctional high-level programs, and the jobs end up being delivered by a combination of site engineers and general foremen who are planning on 6-week look-ahead programs on construction sites. And then they tell the P6 programmer what they've done, and they adapt the program afterwards. It should be insane. This should not be true, but it is. Multi-tier procurement. This is sort of old stuff, really. Project 13 pointed to the fact that you've got a tier 1 contractor, then tier 2 contractors and tier 3 contractors, all man to person or person to person marking all the way through, is generating huge amounts of waste in the process. And Project 13 talks about 20% potential saving in cost by getting rid of that kind of inefficiency at the commercial boundaries. Labour utilisation. Again, if we were in manufacturing, we'd know. We don't know. We don't know how much time people are actually working. The few bits of work that have been done on this indicate that on construction as an average, it's something like 40 to 60% of the time people are actually working productively. When you burrow into why is that? Why are they only working 40 to 60% of the time? It's to do with things like they can't get access to the work face. You know, that for whatever reason, if someone hasn't finished their job, so I'm standing here waiting for them to finish. I haven't got the bit of kit I need. You know, my spanner, I've got the wrong size spanner, and that's the thing, and I didn't know it was that. I haven't got the materials I need to do the job. Or I'm walking to the welfare facilities, which happen to be half a mile away. That is what drives those very low levels of utilization. If you speak to people who work on linear infrastructure, they'll tell you it's down in the 30% range. And if you work on possession work, it's down at less than 10%. So that's a gross underutilization of human effort in doing all this sort of stuff. Plant utilization, we know even less about that. But what you do know, a very good friend of mine, another Irish emigre, a chap called Damien, who's a fixer. He goes in on big construction projects when things are going wrong. And he said, I said, Damien, so what do you do? He says, well, I do two things. He says, when I'm put in to fix a job, is the first thing I do is I sack someone. I said, Damien, why'd you do that? He said, I don't know, but it sets the right tone. and then I said, what do you do next? He says, I off-hire everything. I literally off-hire everything. And he says, do you know what comes back? He says, within a week, I'm lucky to have got 50% of the kit back. The rest of it was sitting around the back of a shed and no one had bothered to off-hire it. So we've got, again, very low levels of utilization of plant, as indicated by that sort of anecdotal story. And then, to sum it all up, you get to this position, well, this is really odd. This shouldn't be true, should it? It shouldn't be possible. We're living this neoliberal capitalist economy that's designed to drive inefficiency out of the supply chain and all the rest of it. And yet it doesn't. It hasn't driven this waste out. This shouldn't be possible. And in fact, what we've got is a situation where our supply chains are set up in a manner where the companies actually benefit from and rely upon waste. And you say, no, that can't be right. But ask yourself this question. If I am a concrete supplier and the designer overspecifies concrete, am I A, happy, B, sad? I get to supply 20% more concrete because the designer's overspecified. Well, great, bonus time. The concrete installer, the contractor who puts the concrete, has a bad day, pours it all on the floor by accident, doesn't vibrate it properly, has to smash it all. Is the concrete supplier happy or sad? Well, they're delighted. The same is true of the contractor. The contractor is sitting there. If the designer is overspecifying, well, what do I care? Brilliant. I get to build more. My fee on the build cost is greater. If the designer is asked to do the job 3 times because the client hasn't sorted out the regulatory approvals in time or has to change stuff because they haven't got planning permission, do you think the designer's upset? Well, individually, they might be as miserable as Sing because they're getting bored. But the company is sitting there going, the perfect job. I've been paid to design something and it's never going to be built. I'm never going to get sued. And I get to do it again and again. So you have this perverse situation where we're all very focused on not wasting anything ourselves. All of those companies are trying not to make mistakes. They're trying not to be wasteful in their own work, but they are deeply, deeply benefiting from the waste of others, or at least it looks like that from others in the process, to the net detriment of the total process and the value to society. And this is really, when you put this in the context of climate change, limited capital available to provide social outcomes through housing or schools or anything else, and we are pouring away money and resources and people's time wasted doing stuff over and over again. This is unacceptable as we face into the challenges we face, and we must improve. Yes, go for it. Yeah.
And I empathize with a lot of what you're saying. My background is heavy civil engineering.
Yes.
Now I know nothing about building because the difference between building and civil engineering is chalk and cheese. My wife would be better at building than I would be. Actually.
Yeah.
However, and I empathize with a lot, particularly when it comes to the aspect of waste in concrete. And I could have been blamed myself for a lot of it when you say, oh, that measures 100 cubic meters. Let's get 110, so that's waste. However, your address deals with, I think, as I understand it, you're dealing with projects from the start. You're not talking about them from estimation point of view. And I think estimation, because it's so competitive, contractors win projects at a very, very keen cost. And then when we come back, we kind of look for everything to kind of increase the price. And that is part of the problem. But a lot of the genesis of our problems, in my view, is in that stage, in the estimation, because it's so competitive in the estimation part. I was wondering, have you got any views on that?
Yeah. So look, what's really interesting is, having set out this miserable picture, when you start going, why is it happening? What are the root causes? What is driving these behaviors? You're absolutely right. I mean, I did time with a contractor, and I remember sorting out a problem. The resident engineer hadn't detailed up the drawings. I'd actually come from a consultant organization. I knew what to do. So I modified the drawings. I said, put this amount of steel in it and just put in the corner site instruction. And I gave it back to this very junior resident engineer who gave it back to me. And that developed into a little habit. So whenever he had a problem, I would, from a contractor side, I'd just tell him what the answer was. He would give it to us as site instruction at that point. He took responsibility for it. But when my project manager for the contractor found out I was doing this, he nearly sacked me. And he didn't sack me because of design responsibility. He says, look, the more mistakes they make, the more we're standing around wasting time, the more opportunities there are to address the problem you're talking about, which is we lowballed this. To win it, we went in there and we were relying on problems in the construction phase in order to get to a position where we're profitable. I know commercial managers of the biggest, some of the biggest contracting companies in the UK. And one of them says to me, is the worst possible job for him is one where the design information is good. They love jobs where the design information is obviously deficient, because that means there's going to be change. And when there's change, they get to win. He says that I can quote you lots of examples if I want to, he said, where we go in at 80% of what we think the job will cost to win it, confident that we will take that 80% to 110 or 120% on the basis of change and so on. And this is a very important root cause, but it's not the only one. Actually, there are a series of others that are problematic in this whole sort of setup. But what you get as a sort of punchline on something like this is a sector we suffer from gross and endemic waste in most, if not all, of our processes. The opportunity for improvement is absolutely huge. Efficiency improvements of between 30 and 50% are, in my view, achievable. And I'm talking about land take, I'm talking about environmental impact, I'm talking about material consumption, all the rest of it. And I'm not alone. Nick Smallwood, who's the head of the Infrastructure Projects Authority in the UK, is wandering around and he tells government the number's 40% in his opinion. So and it's amazing how when I speak to seniors in industry and we just start adding it up, everyone gets the numbers that look like this. It should be shocking to us, but nonetheless, they are what they are. Okay, so I'm going to scoot past this and talk about what do we do about it. And one of the first things I'm going to say, some of you may be familiar with, all of you will be familiar with this idea. It's something, it's called an influence time curve, sometimes called the McCann curve, which basically says your opportunity to influence outturn costs is much greater in the first phases than later. McCann was an architect, by the way, who drew the McCann curve in 2004. Paulson was a construction manager who drew the curve in 1974. And so I choose to credit Paulson with drawing the influence time curve and not putting his name on it, by the way, unlike the architect, which says something about architects, perhaps. But what this is saying is that we have to invest appropriately in the design and development of the early stages of project, whether it's picking up the contracting strategy or it's setting the tone. That first phase, if you don't do it then, it's really, really difficult to do anything after that. Now, lots of people take that to mean, what we need to do is invest in the first phases. And unfortunately, I wish it was as simple as just spending money at the beginning will make the world a better place. It's not. And there are a load of organizations who will happily take all of the money that you pour on them at that first phase of the job and not give you any value at all. So you shouldn't read this as saying spending money at the beginning of a job definitely generates benefit. That's not true. You've got to get the right people. You've got to spend the money wisely. So I would say understand that as meaning you need the right people in the room at the beginning to get a good answer, and you need to properly resource them. That's what I would take that curve to mean, because your critical decisions are baked in very early on. But too many clients have bought into the idea that they just spend money at the beginning, get loads of consultants, get it. It doesn't work. You gum the problem up. You need the right people in the room at the beginning with the right skill sets, the right insights. And then you need to properly resource them. It's that way around. Don't just chuck money at it, but the beginning is where it matters. There's always things that benefit you more than other things. And again, sometimes we come at problems on a very broad front and we're not sufficiently strategic in understanding where to exercise pressure. If any of you do martial arts, you'll know that hitting people in certain areas generates much better reactions or results than hitting them in other places. And this is a piece of work we were doing for HS2 probably 2 years ago now. And we were challenging the sort of conventional wisdom which says that low carbon design increases cost. particularly when you're talking about embodied carbon, because the industry is turning around to clients and saying, oh yes, what you need is magic cement, which doesn't exist. It's got loads of risk associated with it. Or we've got to get GGBS in and PFA, and we haven't got any of that. So that's going to push the price up. Or we've got all sorts of other things that are going to reduce carbon. And unfortunately, there's a cost goes with it. And there's a sort of like intuitively, we feel like more functionality should increase price. In general, that's a truism. Is if I ask for more features, I pay more for them. If it's not like that, you're a bit surprised. You know, why would it be like that? But when you're dealing with highly inefficient systems like this, with 40% to go for, actually, you can have your cake and you can eat it. You can take carbon out and cost at the same time. And this is very true on embodied carbon in buildings. And so this was put together for Euston Station, where we said, look, you think you're going to increase cost by reducing carbon, and that's not true. The bottom 4 things you do there will reduce cost and carbon, and those are the things we sensibly need to do first. We need to improve our optimal, or make more optimal strategic choices. And that's things like, if you've been following Euston, you'll see that they went from 11 platforms to 10. Now that's a big shift, but that's a strategic choice. You know, whether we're going to provide a certain level of coverage on a roof or not. These are strategic choices. Someone was saying before, don't build it type questions. Do I really need it? That's a strategic choice. Next is lean design and lean construction. Is making sure that the elements are designed lean, that you've picked the right system, structural system or whatever it is, and then you've designed it lean. You've pushed your designers, and then the contractors are operating lean using 3D modeling tools, as you said. BIM, use that. Why aren't you using that? Why aren't you getting proper estimates to the nearest 1/10 of a meter cubed? Why are you just still reading this off on site with people and tape measures and so on? Error elimination is another one, is why do we make errors? And there's a lot behind why we make errors, why error prevalence is so high. Ruth Todd, who's the commercial lead on HS2, and I had a conversation about this a while back, and she was telling me that in manufacturing, her origin, she was, I think, Jaguar Land Manufacturer, she said, your error rates are like ours were in the late 1980s. And, you know, that sort of 25% of our total costs are associated with recalls or line rejections or whatever it was in the process. And I said, what are they today? She said, oh, much less than 1%. I said, how did you do it? How did you do that? How did you achieve that? How did you go from where we are and you were to this other place? She said, no, we worked on it. We identified it as an issue. We got to the bottom of the root cause, and then we just ground it out of our processes. We came up with ways which reduced the likelihood of making errors. Most errors on construction sites, or many errors on construction sites, are about a lack of clarity about what you've got to do, that the information is not clear, so people make mistakes. You know, people don't know what they're aiming for, and so they make mistakes. Or they're to do with all sorts of things that are deficiencies. You've got a question there? Yeah, go for it, yeah.
Hi, Ed. A couple of questions coming online. One from Kieran Feehan, who says, it's easy to say that 30 to 50% efficiency improvements are possible in theory.
Yeah.
Can you give any examples from your professional career where you've achieved improvements of anywhere near this scale in real life? Really putting it up to you there.
Yeah, no. So I can give several, and I'm going to actually, I think it's my next slide. I'll pick up this point, but okay. I have several examples where designs that have been done, teams have gone in, optimized them, and taken 25-30% of the material out of it. There's a guy called John Nolan, actually, who's the president of the iStructE, he was the president of iStructE, and he's got a brilliant business. I mean, he basically gets employed by contractors to redo designs. And if you say to John, well, you know, how much steel and concrete do you take out on average against it? So this will be mainstream consultants are producing drawings. They've gone out to tender. Contractors won it. He then comes in. He might come in at the tender stage to let them know what they can do. But then he's stripping out. He says, I take 25 to 30% of the materials out. It's every single day of the week, all the time, every time. So it's not hard to find those, and I'll show you. So it sounds astonishing. We did a big roof structure on a major roof. So you know, so several thousand tons of steel work in the roof. Took 2,500 tons out of it in 4 weeks. People are simply not optimizing these structures at all. They're not even trying to. So there are lots of examples, and to that point, if you bear with me a second, I'm going to give you some evidentiary and more sort of firm evidence base for that. But this slide, what I'm basically saying on this slide is that you get rid of this stuff by coming at it strategically. Don't try and do everything at once. and do those things which offer multiple benefits. So, for example, carbon capture and storage, great. You know, in principle, that gets carbon out of the universe, or captures CO2 out of the sky. Well, we haven't got a technology that does it. It costs a fortune. Why were we doing that before we lean out our design? Surely we lean out our design, get cost and carbon benefits, and come back round on these other ones later. Yes, so this is a study that was done. It's probably the most underreported and most important study in our sector. It was done back in 2008-9. This was a second round. It was a report called Changing to Compete. You can get it online if you want. And they looked at hundreds international comparators, engineering projects, so water treatment works, power stations, this sort of stuff. And what they found was that the productivity, what they did was they normalized the sets, so that they would say, so that you could make comparisons like megawatt hours, megawatt capacity installed per £1 million invested, those kind of normalized metrics. So they would strip out the differences and then they would make those comparisons so that you could do fair comparison between projects. And what they found when they did that was that productivity measured like that, it wasn't, you know, if 100 is average, it wasn't you're 1% better or you're 1% worse. It was 25 to 30% better or worse than average. That the best projects aren't a little bit better than the worst ones. They're miles better. And the worst projects aren't a little bit worse than average. They're miles worse. And many of us who've had, if you've ever worked on big award-winning projects, you know, they're a dream. You know, and everyone smiles and you know you're nailing it every which way but loose. And then you think about the nightmare jobs where it just didn't work, the team wasn't right, didn't gel, decisions were poor, and you're just hemorrhaging cash over and over and over and over and over again. And so this is really, really important. It tells us that at our best, we're 25% better than average, and at our worst, we're 25% worse. What we really need to be focusing on is dragging that long tail up. And so to the question that's being asked there, it's not me. This is about projects out there. They're not 20 to 30% better. They're almost twice as productive as the worst. The best are almost twice as good as the worst when you average that lot out. And I think we over-focus on innovation in our sector. I know sounds absurd to say we over-focus on innovation in a sector which has so little innovation in it. But actually, the first thing we need to do is focus on getting our worst to be as good as our best. That's where we need to drag a long tail of poor performing teams to a position where they're performing well. And really that's where you need to be innovating from. What innovation does, it takes your best forward. And that, while simplistic, I do think we talk a lot about innovation. We don't talk a lot about continuous improvement and focusing on doing the knitting to get our worst performing projects and teams to be as good as our best. And I think it's nice to talk about digital drones and all the rest of it, but there's a lot of work to be done in the sort of more fundamental space as well. Error elimination, I'm sort of slightly looking at the time. I've talked about this. I would direct you to the Get It Right initiative. There's a comprehensive body of work there which explains these outrageous claims and does a lot of work on root causes of error in construction. I haven't got time to go into that today, but that's how you get to that 21% number I told you about on error elimination. And the huge, you know, the thing that I'll show you a picture actually, so this will sort of make the point. If you just reflect on that, unfortunately, a very commonplace occurrence in construction projects. You know, I don't know why they came up short on the pour. I don't know whether this was the concrete pump broke down or they didn't bring enough, or they, you know, what it was that went wrong that day. But just think about the indirect cost consequences of that error. So to do the job right, they're short 5 or 6, whatever it is, 5 cubic meters of concrete. You know, it's a few hundred quid's worth of concrete. They're short. This error, if that's a critical path element, by the time you've stripped it, you've assessed it, you've gone back to the technical authorities and the designers and decided what on earth you're going to do about it, whether you've got to break it all down again, whether you can start with a cold joint, whether it's structurally significant, whether you've got to scabble the bars, you rebuild it, blah, 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 blah. This is weeks and weeks and weeks to sort out that problem. So you get this massive asymmetry, an apparently minor error. You've come up short on a concrete pour. Has the potential to generate tens, 20, 30, 40,000 pounds worth of consequence for an activity that you'd be being paid a few £1,000s to do correctly. And so that's very important when you understand error in construction is the asymmetry, particularly in relation to the indirect costs. The direct costs of fixing this will probably be quite small. The indirect costs, the flow through costs are very, very large. One thing we don't do nearly enough is, I mean, if I were to ask you, is civil engineering a process? You know, is design, construction, commissioning, is this a process? I imagine most of you put your hand up and say, yeah, it's a process, of course it is. And then I say, how many of you ever learned anything about process engineering when you were at college? How many of you are familiar with the standard toolkit of a process engineer? How many of you have the language of systems engineering? The answer will be very few of you. And if you have got it, it's because you did a master's in water engineering or something. You know, most of us are not educated around process engineering. We're educated about project delivery. We do project delivery. We don't do process engineering. If you're a process engineer, you put the process at the core. You understand your process. You have ownership of your process. You articulate every step. You capture data on it and you continuously improve it. And we don't have that habit. Do you know when the I-beam was patented? 1856. You'd think we could have moved on a touch, really. When was the last time anyone took the process of installing manholes or pipes and really looked at that and said, do you know what? I think after the standard details were developed in the 1960s, we might have done something to change the way we do this. Or did we really find the perfect way for all time of building manholes when we did it in the 1960s? We just don't think like that. If you were in automotive, they wouldn't stop. They would turn around and go, it's got to be a better way of doing this. No, that manhole ring, surely we can shave a little bit off. Is there another material? Is it a different size? Do I invent a new lifting kit? Do I do something to make it better tomorrow than it was yesterday? And we don't have that habit on the whole. And I'm generalizing wildly. And of course, there are examples of people in our industry who do these things. But if you look at us as a group, we're not doing this well enough yet. One of the things that's really interesting, I think we missed a trick on lean. So there was a big push. Those of you who are of my generation will remember Egan and Lathan and the reports that were done in the late 1990s, which basically looked at construction. And as I mentioned earlier, periodically we criticize ourselves. They turned around and said, you need to look at other industries to learn from them how they do that. And they would have said things like I've just said, focus on process for them. One of the mistakes, we didn't read what Egan wrote well enough, and we thought he meant do lean like they do in manufacturing, because that's what we set out to do. We said manufacturing looks like construction. Let's take lean and let's apply it to construction so we get lean construction. The problem with that is our process is not like manufacturing in that sense. We have bespoke design, bespoke commissioning, and the front end of ours is the generator of most of our problems. The problems are not construction related. They all originate. When you track the root causes back, they come back to earlier, whether it's the procurement and the deal that's been done, or it's the poor quality of the design information, or whatever. That's where the problems reside whenever you start digging into this. And one of the things that we didn't do either was we didn't understand that our inputs are not the same as their inputs. And there are a couple of really important differences. So infrastructure projects, we have as an input what you might call social capital. If you think about what's killing infrastructure projects in the UK, and I'm sure it's the same here, is that the politicians go flaky on them, or the community says, I'm not prepared for you to do that. I don't like this. And then what happens? Well, it slows down. Everything slows down. And then the prices change. And then the political administration changes. And then you've got to go again, and you've got to redesign it. And then maybe you've got to reconfigure the entire thing and reprocure it. And social capital is it's the permission of society measured in it's an input, which is the permission from society to do the project. Yeah, I'll draw it to a close now. And that's not a thing in manufacturing in the same way. But just if you focus on that one, if you view it as an input, it's something we can enhance by working with communities to make sure that what we're doing is what they want. And it's something we can lose, as you see occasionally on projects when they knock down a medieval forest, which didn't need to be knocked down, and all of a sudden the community goes mad. Go for it, yeah.
Hi, Ed. We have another
question,
observations,
yes.
Stroke question in from Ian Swartz. And it's kind of referring back to the design part and bidding part that we were talking about earlier. You're saying part of the issue is the process when consultants put in bids, Says when we prepare bids, we're told that we won't get the job at that price, so we cut the price, as you were saying earlier. He said then we're told we've only got X number of hours to do the design. And he then goes on to say that design fee is a fraction of total project costs. He said 2 to 3% in many cases, if a designer is lucky, when the contract is awarded on a big project, say 100 million, 200 million project. And he's saying there's incentive then for the contractor to redesign to generate savings. And he said, he makes the point that the redesigner often ends up getting paid more than the original designer.
That's right,
So just
John
be
Nolan,
interested to
that's
hear.
exactly what he does. Yeah. Yeah, no, look, he's absolutely right. But you know, you have to ask yourself, why is this the case? You know, what is the relationship that we as the designers, the contractors have with our clients that we haven't managed to explain to them that the consequence of buying the cheapest bit of everything in aggregate generates a suboptimal outcome? We haven't managed to do that. Now, that's down to us, frankly, working with our clients to explain this clearly and with evidence to show that, because you're the commentator, I completely agree with it. And we see it over and over again, program-driven design, people just risk-averse, program-driven, it's going to be fat. I'm going to be able to look at it and say it stands up. I'm not even going to turn my computer on. You know, it's not going anywhere, but that's what I can do for that fee. I can't optimize. And the client thinks they've done a great job. The QS has told them, oh, I saved 2% on the design fee. Well, yippity-doo-dah. Building costs has just gone up 20%. Anyway, just returning to, so I agree, but we need to address that, working with our clients to get them to understand where their best investment lies. And often it is about investing in planning and construct and design with the right people. Because as I said, if you just pour money on people, you don't get the outcomes. You've got to decide who you want to work with and then properly resource them. That's how you get good outcomes. But just on this social capital one, and then I'll talk about land and ecosystem as well. Land and ecosystem are a huge input to infrastructure projects, and they're not meaningfully that. If you've got a factory and you're making cars, it's not an input, you've got it. Whereas for us, not having enough land to optimize the construction operations, whether it's lay down or stockpiles or its access routes, it's disastrous. It really throttles effective construction activities. And with land goes ecosystem. If you take more land than we need, we're damaging ecosystems that we don't need to damage. And in that space is also our impact on the environment. These, you can view those usefully, I think, as inputs that we need to look after carefully. We need to develop them and not waste them. And too often we do. We waste that kind of part of it. And again, they're not really things in traditional lean. I'm going to draw a line under it. Yeah, we could go on. There's a much longer version of this for those who could put up with it out there. There are specific examples on this deck. I'm very happy for people to share the deck, specific examples related to some of the things we're talking about. But for now, enough. No, I've gone on. Yeah. A cheery note. I'll leave you with. And if you, yes, we'll be going off and sorting this out afterwards. So thank you very much for your attention. Hopefully it was interesting.
Wow, is all I can say. That was just absolutely brilliant and so interesting. And I come from an area that I really, I'm not a civil engineer, don't know civil engineering, but it was just really, really brilliant, Ed. And I think that starting point of the mode of being is damaging the planet, that absolutely has been the case. We know that. But we also know that engineers should be the providers of solutions now. And the examples you gave about resilience around net zero, absolutely. But you look at the construction sector, and I'll kind of just look at Ireland, largest generator of waste. So, you know, that's saying something about the sector. And what I found really interesting, Ed, when you were talking about productivity and effective and efficient, and the 0.5% of projects being delivered on time and on budget and delivering as anticipated. You were talking about that in kind of that context of efficiency, and it brought my mind back to kind of the kind of environmental protection, which is my day job. And we look at the evolution of environmental protection. And the first evolution was, please pollute less. So that was the starting point. And then we moved on and saying, please be more efficient. And we kind of discovered that that really didn't deliver. And now we've moved on to transformation. and we need to transform sectors. And what I would say is, although you were framing it in efficiency and framing it in productivity, you're talking about transformation of a sector and complete transformation, which is really needed. And then in that context, what does sustainability mean? And I know Engineers Ireland, we have our own sustainability strategy, but sustainability covers the environmental, which you were touching on. It covers the economic, because you're wasting money, here, but also that social piece and that social license to operate. And again, we're seeing with infrastructure projects in Ireland that there isn't on occasion that social license, and that will stop things. You can have whatever planning permissions, whatever you want, but if you don't have that social license and people seeing the value, then you are not going to move forward. So I was going to leave it at that. I think that focus on getting the worst to be as good as the best, not only the construction sector, I'd say, I think that's a kind of in general. And the last maybe is a challenge for the Irish audience, because you were talking about embodied carbon. We have a climate action plan in Ireland. For each of the sectors, there's carbon budgets. Embodied carbon is there. There's an ambition to remove around 2 million tons of embodied carbon, but there's no specificity on how. So when the Environmental Protection Agency produced our projections, we've just discounted it, because we said, you're not saying how you're going to do it. It needs to be done, but it's just words on a page or numbers on a page at the moment. So I think the challenge for the Irish sector now is removal of embodied carbon. So I'm going to call on Keith now, but Ed, thank you so much. I think that was just such a stimulating talk. Thank you.
Thank you very much, Laura, and thank you very much indeed, Ed, for your most passionate speech. It really is super to listen to you. As chair of the ICE Local Association here in the Republic of Ireland, I'm honoured to be in the presence of our president. I'm also honoured that we have been entertained here by Engineers Ireland, and indeed as a proud member of both institutions. It's great to see this collaboration. It's something that has been built over many years, and we hope will continue long into the future. So I'd just like to thank again Ed for his terrific speech, Laura for your remarks, John Power for entertaining us here at headquarters, and special thanks to Maureen and Alec at the back of the room, who have looked after the technology for us this evening. And in closing, I would just invite, on behalf of John Power and Engineers Ireland, those here in the room to join us in Cafe Clyde for some refreshments. And thank you very much indeed, everyone.